All right, we got some more slope, everyone, okay? I hope you are ready for some slope because I am ready for some slope. Okay, so what we're going to do is we're just going to look at one example over here. A nice short video, hopefully. Find an equation of the tangent line to the graph. What happened to my G? To the graph of x to the fourth y squared equals 144 at 2, 3 and 2, -3. So this is not a function. If we solve for y, we'd get a plus or minus. Certainly don't want to take the derivative of a plus or minus. There are actually some ways of making this derivative problem a little easier. You could do what we did last time. Take the derivative of both sides with respect to x. But in this problem, it's actually a little easier, I think. If you divide both sides by x to the fourth, right? This is 144, x to the -4. This is optional. It just makes your life a little easier. That's supposed to be an O. It looks like an S. Spational. All right, and now we ddx both sides. Okay? So again, ddx both sides. When you take the derivative of the left-hand side, it's going to be 2y times y prime. Implicit differentiation. Derivative of the right-hand side, bring down the 4. Don't know what that number is. 400 plus 160 is 560. 576, I think. And subtract power. Now to solve for y prime, we just divide both sides by 2y. -576, x to the -5, divided by 2y, which can be simplified a little bit more, right? They're both even, so they cancel. We get 288 x to the 5th. We can put that in the bottom. Negative exponent means it goes to the other place. It goes to the bad place. And there we go. That's our derivative. But remember, we want to find the tangent line. Oh, the tangent line at these 2 points. So we need to find the slope at each of those points. Okay. So part A, right? It's going to be, what is the slope at 2, 3? We just plug in, well, what is y prime at 2, 3? It's going to be -288 over 2 to the 5th, which is 32, times y, which is 3. So the slope is going to come out to some number, -288 divided by 32 and 3. Oh, -3. Real nice slope. So to get the tangent line, remember that's y minus the y coordinate, which is 3, equals the slope, -3, times x minus the x coordinate. This is the equation of a line. This is point slope form. This is one of our answers. We'll check our answer in a bit. We need to find the other slope as well. So at 2, -3. Again, I'm just going to copy down the derivative. The derivative was -288 over x to the 5th times y, I think. So at 2, -3, the slope, we can think about it as m if we want. -288 divided by 2 to the 5th, which is still 32, times y, which is -3. Okay, so it's the same number, just now we have a negative, so it becomes positive. So again, y minus the y coordinate is going to be y plus 3, subtract a negative, add a positive, equals the slope, which is 3, times x minus the x coordinate, which is 2. So we got 2 tangent lines for you here. And let's see if I did my stuff correctly. Let's see if this is the actual tangent line. All right, so let's go over to our graph. And we're going to do some exploration. Our function is x squared, x to the 4th, y squared equals 144. is not a function. Our relation is given by this equation. So we have a tangent line. We said one of our tangent lines is y minus 3 equals negative 3 times x minus 2. Oh, you love to see it, right? Look how pretty that looks. It's just skirting right up against the function at the point 2, 3, which is exactly what we wanted. Ah, I love it. You love to see it. And the other one was almost the same. We changed this to a positive and this to a positive. This is the equation of our other I like that. Don't get distracted by this. Beautiful tangent line right here. It's skirting right up against it. Almost looks like a normal line here, but I don't think it actually is. All right, so tangent line, checked our answer. And it looks beautiful. Good luck. Bye-bye.